Hey everyone, in this video we'll be going over some AP Physics 1 work practice problems. So this is part of the work, power, and energy unit, which I believe is unit 4. So to start, let's look at number 1. How much work is required to make a car of mass 4,000 kilograms move from rest to a speed of 25 meters per second? Now the main points we have to underline in this in the first problem is how much work. So we're solving for work. How much work is required to make a car of mass 4,000 kilograms move from rest, so we know that the car starts at rest, to a speed of 25 meters per second, which is our final velocity. So work would be in joules. So work is in joules. And then this is our mass, which is m. And then rest is our v naught. And then speed of 25 meters per second is our v final. So we know that the car is moving. So from this, we can assume that the car has kinetic energy. Since we know that the car has kinetic energy, we can use the kinetic energy formula. The kinetic energy formula is change in K, which is kinetic, is equal to work is equal to 1/2 mv squared minus 1/2 mv naught squared. So 1/2 mv squared minus 1/2 mv naught squared. The m stands for mass, and the v squared stands for final velocity squared, and then the v naught squared, which is the v and then subscript 0, stands for initial. So in this problem, we are given that v naught is equal to 0, v is equal to 25, so meters per second, and then w for work is unknown, and then mass is equal to 4,000 kg. So let's just go ahead and plug this all into our big equation here. So when we plug it in, we get 1/2 times 4,000 times final velocity squared, so 25 squared, minus 1/2 times 4,000 and times 0 squared. Now we can go ahead and just simplify this into 125,000,000, and then minus 0, because that was, since we plugged in 0, that second part of the equation would become 0, and it would just, or you could just completely cancel it out in the beginning once you see that v naught is equal to 0, or you could just plug it in and see what happens. So we have this number, and that is nothing but 1.25 times 10 to the power of 6. And we can't forget our units in joules. So this is our final answer. 1.25 times 10 to the power of 6 joules. So let's quickly review. So initially we underlined what we're solving for and our variables that are given. We are solving for work, which is in joules. We're given mass of 4,000. We're given a v naught of 0, since it starts at rest, and a velocity of 25 meters per second. Since we know that the car is moving, we can go ahead and use our kinetic formula. So that would be 1/2 mv squared minus 1/2 mv naught squared. And once we plug our values in, we get 1.25 times 10 to the power of 6 joules. So let's take a look at number 2. How much work is required to stop a 1,200 kilogram car traveling at 15 meters per second? So let's underline our important information here. So we have how much work, so we're solving for work, which is in joules, is required to stop a 1,200 kilogram car, so that's our mass, and is traveling at 15 meters per second. which is V naught. And then, as you notice, how much work is required to stop. So when we see that required to stop, we know that our final velocity is 0. So we can say that at the end, the car will stop. But currently, the car is traveling at 15, so we know that the stop word is V, which is 0. And the 15 meters per second is V naught. So let's go ahead and just write down our information here. So we have V naught is equal to 15 meters per second. We have V is equal to 0 meters per second, because it says we have to stop the car at the end, so our final velocity would be 0. And mass is equal to 1,200 kilograms. And what is our work? Now, let's go ahead and just plug this in to our kinetic formula. And we're using the kinetic formula because we know that the car is in motion, so we can just, that will be kinetic energy, so we use that for the formula. So change in K is equal to work is equal to 1/2 mv squared minus 1/2 mv naught squared. Now, if we plug that in, we get 1/2 times 1,200 times, and our final velocity is 0 squared, minus 1/2 1,200 times 15 squared, and then you get negative 135,000, which is equivalent to 1.35 times 10 to the power of 5. And then our units, so we'll write this in joules. So that's our unit for work, and that'll be our final answer. So let's review one more time. We underlined all our information, and since it said the car is going to stop at the end, we know our final velocity is 0. And we just plug that into our kinetic formula because we know that the car is in motion. So it has kinetic energy. And since it has kinetic energy, we can use the formula for kinetic energy. And we just plugged in our values and solved from there. So that was simple enough. So number 3 is where it gets a little tricky. So a baseball of mass 140 grams traveling at 32 meters per second moves a fielder's glove a distance of 25 centimeters when the ball is caught. What was the average force exerted on the glove by the ball? So our important information here is mass, a baseball of mass 140 grams. Now that's important, but that's in the wrong units. In physics, we're going to use kilograms. So this will become 0.14 kg. So that's our mass, 0.14 kilograms, and is traveling at 32 meters per second, which is velocity, and moves a fielder's glove a distance of 25 centimeters. So this is our distance or displacement, and this is 0.25 because we're not going to use centimeters, we're going to use meters in physics. So we have to use 0.25 meters. So we're just going to convert that, and that'll be our displacement. When the ball is caught, what was the average force? So we have to find force here. We have to solve for force exerted on the glove by the ball. So let's just write out our information and what we need to find. So we have mass of 0.14 kg. We have a velocity of 32 meters per second. We have an initial velocity of 0 meters per second because it wasn't explicitly given. So we can just assume that it's 0. And if you just think about it, the ball is in the fielder's glove or whoever's throwing it, so it would have initially started at rest and then be thrown or hit at 32 meters per second. So then we have D for displacement at 0.25 meters, and then force is unknown. Now, what formula can we use here? one thing that you have to know before being able to solve this problem is that there are two formulas that we have to use here. There are multiple formulas to solve for work, but there's two very important ones, which are K is equal to work is equal to 1/2 mv squared minus 1/2 mv naught squared. But then we also have work is equal to force times displacement. There are, of course, other formulas that equal work, but these are the two main ones you need for this specific problem. So work is equal to force times displacement. Now, you can see how that is important because we're not only given mass and velocity, but we are given displacement and we're trying to find force. So how would we incorporate force and displacement while also using mass and velocity? We would have to set these equations 1/2 mv squared minus 1/2 mv naught squared together. So force times displacement. So we're setting these two equations against each other because since both of these equations equal work, we are able to set them equal to each other because they will always be equivalent when, of course, when you're given the right information. They will always be equivalent because they both equal the same amount of work. Now, once we set them equal to each other, we can go ahead and just solve this out. So we can do 1/2 times our mass of 0.14 times our velocity of 32 squared minus 1/2 times 0.14 times 0 squared is equal to force, which is unknown, times displacement of 0.25. Now, once you solve this out and solve for force, you should get force is equal to 286.72 newtons. So this will be the final answer for solving for force. Now let's recap. In number 3, we took our mass, our velocity, and displacement, and we're trying to find force. So we have those three variables, and of course, the v naught is equal to 0, but that wasn't necessarily used here, except for canceling out. So with these four variables, we are able to solve for force by setting both the kinetic formula and the work formula equal to each other. And once we plug in, you get our final answer. And remember, the newtons is the units for force. So don't get those mixed up. Joules is for work, newtons is for force. So those are the three problems that I wanted to go over in this video. I hope you learned something, and be sure to watch out for the next video when I go over the rest of this worksheet.